Okay. So now we're working on continuous IV and short infusions. There we go. Okay, so now we can advance. All right. So the last video we talked about was IV bolus, which is the simplest situation. But now we're going to, I will go back here. Now we're going to be talking about a continuous infusion. So if we're going to give a continuous infusion, it's a very different situation, isn't it? Rather than giving one dose, boom, and having it go in and cause a Cmax to happen right away, and then for it to decay, we're going to start giving this dose at a certain dose rate, which can be also called a KO, which is an infusion rate that we're going to give. And as we start giving it, the drug is also being cleared. So we have to consider clearance as well as we go to an eventual steady state concentration, right? So once we get to this steady state, we know what that steady state concentration is going to be because it's going to be your dose rate or your KO in this case over clearance. It's just drug in over drug out. We don't have to worry about bioavailability. So that's what your CSS average is going to be. Easy peasy. So you see here that equation, KO over K times V, which we know is clearance, yeah? So drug in over drug out. Simple. We don't have to worry about bioavailability. We may have to worry about salt form. You always have to worry about that. But in most cases, we may give a constant infusion and then you know what to do. But in many cases, we're giving a drug for a period of time as an infusion. So let's say we're giving this for 1 hour. Okay, so from time 0 to 1 hour, we're going to give a constant infusion, but we're going to stop it there. Well, what we need to know is this point here, because that's going to be our Cmax now, isn't it? Because we're going to stop it there, and it's going to start to decay from there. Well, how do we know what that is at 1 hour? Well, this piece right here, 1 minus e to the negative kt, tells us the fraction of steady state that we have at time t. So if we're halfway to steady state, this will be 0.5. So you multiply 0.5 times your eventual steady state, and that gives you your concentration. It probably won't be half at 1 hour, but it just depends on what your K is. So this tells you the fraction of steady state at time t along this line, okay? So if we put the time of infusion in there and multiply this, the fraction of steady state at the end of the infusion, times your eventual steady state, that gives you Cmax, doesn't it? Okay? And then, since we've stopped this drug right here, then we can determine any point along this line afterwards by then adding. So we start with C is equal to dose rate, or KO, I'll put that in, times K times V times 1 minus e to the negative K time of infusion. That's going to give us this much, gives us this much, gives us CSS. This much gives us our Cmax at the end of infusion, right? Then we can do any point after this by adding our peanut butter component on. So e to the negative kt, that would be, this t would be whatever time difference it is between the Cmax and the point we want to know. And then if we wanted to get it at steady state, we multiply on the accumulation function. See how we can just add these pieces parts all together. So this gives us CSS average. This gives us our C max at the end of infusion. This gives us our concentration T time after that. And then this takes us to a steady state. Or we could do it in at the nth dose if we wanted to too. So we have all kinds of options, don't we? If you understand these pieces parts. So once again, if we look at this, CPSS max times e to the negative kt. So we're at steady state now. So CPSS max, the time difference between here and here is tau minus the time of infusion. So if this is tau, the end of the infusion, we're going to give another dose here. Tau minus the time of infusion, that amount of time takes us to steady state, or to C min, doesn't it? So this is our CPSS min. We should have been able to figure that out without needing this equation. You see what I'm saying? All right, let's do the next bunch of equations here. So again, for an intermittent short infusion, if we look at Cmax, if we look at Cmax here after the first dose, this is just Cmax at the nth dose, isn't it? Sure enough, Cmax at the nth dose. How do we figure out Cmax? This piece is Cmax, isn't it? We know this piece is Cmax. This is going to peanut butter it down to whatever time. Last time we had tau minus t time of infusion, but maybe it's not all the way to tau. Maybe we want to know what the concentration is 3 hours after the end of infusion. If we're giving it for 1 hour, that's going to be 4 hours after giving the drug, right? So this difference is what matters, right? Cmax to the time we want to know here, T. See, this is CSS average, this is Cmax, and then this is whatever time after Cmax, or after the infusion. Actually, it's after the infusion because they're subtracting this time of infusion here. You have to be careful. Again, these two concentrations have to be T time apart, because this cannot be part. You can't use this as drug is being added, only if it's falling. Okay, that's important. All right, another thing that's really tricky on these is, and by the way, we could have added a multiple dosing function or a steady state function onto these to fast forward to whatever time after on whatever dose. One thing that's very tricky on these that you need to be aware of and make sure that you think about is the time of infusion and the dose rate. So remember, our dose rate, or our KO, is in amount per time. So usually, let's say we're giving a dose of 1,000 milligrams over 1/2 hour. If we're giving 1,000 milligrams over 1/2 hour, we're giving 2,000 milligrams per hour, aren't we? But we're only giving it for 1/2 hour. So a dose is equal to your dose rate times your time of infusion, or your KO, whatever you want this to be. So this is usually in milligrams or grams per hour. And then your time of infusion would have to be in hours as well. So you're probably often giving it as a 1/2 hour. If it's 1 hour, it's not tricky. Sometimes we give vancomycin over 2 hours and even more. So if we're giving 1,000 milligrams over 2 hours, right? then the dose rate is going to be 500 milligrams per hour, right? But we're giving it over 2 hours. So you have to be really careful that you put the correct dose rate in with the correct infusion to make sure you're giving the right dose. So just know that equation, that dose equals dose rate times time of infusion. Won't let me write that. Okay? It's another little hint. All right, I hope you're finding this helpful. Thanks.